So I'm Akis. I worked on this project. The main goal, as Miha explained, was to write some code to reproduce CAMS forecast charts programmatically. So use Python to generate these charts. So the aims of the project were to streamline this process, which, as Miha said, was kind of disorganized. So different people within the ECMWF, or maybe outside of that as well, had different code bases, different routines, different plotting styles of doing that. So one of the aims was to streamline this process of accessing data through the ADS and plotting the charts. For plotting to use or maybe reuse the EarthKit Python package, and more specifically the EarthKit maps module, and give some functionality of different users to be able to use this tool within a Jupyter Notebook environment to both generate Jupyter Notebooks for training purposes, for example, or generate these charts within a Jupyter Notebook. Now, one of the challenges was bringing different bits and pieces under one roof. So as I said, different people had different pieces of code or different styles of for plotting, like different color scales. So one of the efforts initially was to collect all these. So the mentors gave me some code and gave me different styles and color scales to put them together in a structured way, so we could have a single repository, access that, and generate those charts. Now, for example, some of the styles of the plotting styles look like this, or at least they look like this now. So you have the name of the style. This is for aerosol optical depth, for representing that that variable. You have a list of colors. These are looking nice. They're from normalized RGB values from 0 to 1. Some of them were 8-bit indicates from 0 to 255, and some others were like this, using an older tool, the Magix plotting software, where the colors were in names, and some were found in the documentation, the mappings to those normalized RGB values. So we collected all these together, put them in a configuration file. As you'll see, the project is based on several config files, YAML files, where we handle these mappings, and we put it in a structured way, so you can grab the style that you want to use and visualize the plot in a different way. Currently, there are 8 CAMS variables supported. It means that there are entries in the several configuration files for these variables, and there is a different YAML file, configuration file to handle that. So here you have aerosol optical depth, and in its entry, there are 3 sections related to that. One is data request, which handles data access through the ADS. So the parameters here are used to build the actual data request. To fetch the data, this is the data set that the variable comes from, the type, and the actual name of the variable. You have plot attributes, which handle how to visualize the chart. Now the title, for example, and also a default style. So if the user doesn't provide any custom style or another relevant style for that variable, then the code defaults to a pre-configured style. And also you have a post-processing section where you handle conversion in different unit of measurements or scaling the values. Now this is under forecast.yaml, and having these config files, it's very easy to extend. So if you want to extend to add one more variable, you just follow this template and add one more and one more. So hopefully over time, this will be, this tool will be used to produce many or all CAMS variables. Now, the third and final config file is the one, those two were the default ones, right, pre-configured. Now, for the user to generate a CAMS chart, they have to fill in some values in a config.yaml file. And this is really, the value you want to fetch, the date and time that you will use as a base time, and how many hours ahead is the focus that you're trying to fetch. And also, override some attributes. So in reality, what happens is that you get all of these config files together, and you give priority to the one that the user entered. So if they use a custom style, that gets priority over the default ones, and that goes for all the attributes, the parameters that the user puts in their config. And yeah, this is a CAMS chart for Azure Optical Depth generated. The one on the left is the one that was at the time available on the CAMS platform, and the one on the right is the one that was generated using programmatically generated. Well, they look quite the same. There is an issue counter that we'll explore maybe later. That's where the color bar stretches, but that's for figuring out later maybe. Let me just demo this functionality at least. Just can you see my screen? Can you see the other window?
Yes.
Brilliant. All right. So the code is up there. I'm not sure it's public yet, but you just download it, create the virtual environment for Python to run and install the dependencies, and there are already those config files available. So for example, this is the forecast config file where you have all these different CAMS variables, and as I showed previously, you have different conversion factor and units of measurement, all of these parameters for accessing data and plotting it. So for example, for the, where is it? For the aerosol, the default style is this one, and then you go to the styles file and you see all these, the color list and the different levels that make sense for that variable. You see it here. And the final one is this one, which is the config file that the user has to fill in to access the data. There's a credentials section here as well, where you have the API key from the ADS. So, for example, if we want to fetch particular matter, let's say today, 24 hours ahead. Yeah, then you fill this. I try not to reveal my API key. And you just pass. Oh, one more, you have the where to store the output, and this is this folder, chart PNG, which is this one. And here you can see, particular matter for the forecast the day ahead, right? Let me go back. Another aspect of this project was to have the functionality to generate a notebook, but programmatically. So run a script and output a Jupyter notebook. And again, to do this, we used YAML files, right? We used templates, which they have some conventions, right? So such a template is the one on the right, where you have you generate the template relevant to the Azure Optical Depth. Here you can see the markdown cells, and also there's a chart cell where you actually have the output chart. And this sample template could be used for training or could be used for communication, because in this sample, you explain what the variable is and how to interpret what you see in the chart. Again, it's very easy to add, if you follow the convention, it's very easy to add another template for a different purpose. So you'll see in the config file that there is one more section, which is related to notebook. Right now, the chart only is true, so you only see the chart. Ideally, at some point, we are going to have another option to also reveal the code that runs to do this, maybe to have this end-to-end and have all this information from the template and also have the code and the output chart. And then again, you have the output path where the Jupyter notebook is going to be stored. And this is the notebook you get at the end. Let's do that as well. So for example, if I go here, go to the config and again, today, 24 hours, and then just run this, which will hopefully output here a Jupyter notebook. That is the data, right? So sorry for exiting here, but not this one. If I go to output, notebooks, IRD. So this chart.png is the one that was generated for this purpose, and it's here, so the notebook knows where to fetch it from. And this is the Jupyter notebook that was rendered through that script. So again, for training purposes or anything the users want to do, as long as they add another template, some information about the variable, the chart, and how to interpret what you see. And the last one, which was nice to have, because we put all these to-dos in the beginning and all the ambitious targets, but when we tried to wrap up, we saw that some things were left out. So when I tried to put this in a Jupyter notebook, I said, let's try to produce not just a chart, but also an animation which is available on the platform when you go and see it. So even though this is not in the in the actual scripts and the core utils within the Jupyter notebook that I have added in the repo, you can generate these GIFs. Let me go. Where is it? Here. Actually, not here. Sorry. Let me go here to the config and just I changed the lead time hour to give 6-hour intervals, starting from today up to 78 hours ahead, right? And once I do this, I go here and let me just run off cells. So this notebook, if someone goes to the repo and access that notebook, says what to do before you run it. So you fill in the config file, explains what its parameter is, and really what it does is gets bits and pieces from the core scripts into this, like the utility functions that fetches and merges all these configurations in the parameters, initializing the CDS API client and retrieving the data. Oh, here it's already downloaded, and how to process data and plot it. So this is built. The animation is done through Matplotlib. So what we're doing here is just store its chart, and then put everything together into an animation. which is great if you want to have a dynamic view of a variable. So, for example, here you can see, aerosol. This is probably from the fires in Brazil, right? So you can see how it extends over time. Nope. Ah. So hopefully this project will be valuable to both people in the HTMWF and external users, and streamline the workflow from data access to visualizing those charts, and offers a structured way of doing that. Now, from the very beginning, it was a requirement to use configuration files, and this proved to be greatly beneficial, because not only you can configure how several parameters, projections, or plotting styles, but also you can extend the capabilities of the tool by adding more variables or more node templates, or more custom plotting styles. Yeah, and again, by adding more templates, which is fairly straightforward to add, you can programmatically generate these notebooks, and even though it's not in the core scripts, you can have some kind of animation you can generate it, which will probably, as I say here in future steps, will implement it in the core script, so people can actually generate an MP4 GIF file. So for the future, because I'll try to keep track and add more things here, even though the code for Earth ends today. The plan is to add a few more variables, and one thing that is not present is the main options. So you'll see when you go to the CAMS platform that you can select based on continent or country, and you get the zoomed in charts, and support for more projection, because right now there is the option in the config file, but if you select anything else, it's not really there, so the mapping doesn't exist right now. And finally, to resolve that max level issue, that you cannot really see the difference between the charts published on the CAMS platform, apart from the maximum value of the color scale right on the bottom. Yeah, so probably we'll publish this code to make the repo public, which is here. Yeah, thank you very much.